Now, as this course will focus heavily on the science of health, it makes sense to start with a definition of science that is easy to understand. So this is my definition of science. Science is logic backed up by evidence. Now, when I say logic, I just mean common sense. Simple common sense, like 2 plus 2. If I was to say to you 2 plus 2, what's 2 plus 2? What would you say? 4. Your common sense should say 4. That's logic. But then what if I said prove it? Then you'd have to show evidence. You'd have to back it up with evidence. The easiest way to show evidence is just put 2 fingers on one hand, 2 fingers on the other hand, and count them out loud. There's your evidence. So science to me is just common sense, and then you back it up with proof. And when I go with my own definition of science, I started to realize that science is simple, which is interesting because when I do go into the schools and I'm teaching the children about health and childhood obesity and that sort of stuff, I always ask them, what's your favorite subject? And none of them say science. For whatever reason, they find science very confusing. So they never say science is their favorite subject, whether it's physics, maths, biology, chemistry. But I like to keep things very simple because a wise man once said, if you can't explain it simply, you don't understand it well enough. That was arguably the greatest scientist of all time, Albert Einstein. So if he can keep it simple, why can't we? Now, many people find science very confusing. Now, I've found through my own observation that confusion leads to conflict, and conflict always leads to pain. So I've written it on the board there. Confusion leads to conflict, conflict leads to pain. That conflict can be internal and or external. So if you're confused about something, it could lead to internal conflict. Let's go back to the kids. The children in school, if they're confused about physics, it could lead to some mental pain. In other words, they're like, oh, I can't get it. I don't know why physics is so hard. And that leads to internal conflict, which will lead to pain. What about external conflict? External conflict, let's say they're in a relationship with someone or they've got a friend and their friend says or does something that is confusing, that might lead to external conflict. You're now in conflict with someone else, yeah? And that's going to lead to pain. So I've found through my observations that confusion always leads to conflict and conflict leads to pain. So anytime we're talking about science or any subject, what do we need? We need total clarity on the situation. Because I have found through my observations that clarity leads to harmony and harmony leads to peace or pleasure or harm or love, balance. So we want peace, we don't want pain. So when it comes to studying science, to me, studying science is just studying the universe. Now I've put this in your notes. If you turn to page 2, after it gives my definition of science, it says studying science is simply studying the universe and everything in it. As you are part of the universe, this means by studying the universe, you'll undoubtedly be studying yourself. So when I'm studying the universe, because I'm part of it, there's no doubt that I'll end up studying myself. So to me, science is nothing but studying the universe. And what I've found by studying the universe is that the universe is electromagnetic. And that's in your notes as well. The universe is electromagnetic. Now, what does that mean? Well, a famous guy once said this about electricity.
Electrical, how does that come in with our understanding? Are we electrical people? If I want to change, and many people out here want to change how they're living against nature and become in balance with nature, what would we do?
Electric food. You ask if we are electrical. If we were not electrical, if we weren't electrical, we would not be able to move. Just by the movement of our heart, the palpitation of the heart, which is 6,000 pounds per square inch pressure, is pushing against. What moves the heart? There could be no movement unless that movement is electrical. So the food should be electrical, which is nutrition.
All right, so he says the food should be electrical and we are electric beings. And he says, without electricity, we would not be able to move. So if the universe is electromagnetic and we're part of the universe, we're living organisms inside of the universe, that means we are electromagnetic as well. Now, what does that mean? Well, electricity, and this is in your notes, electricity is the flow of electrons. The flow of electrons. That's all you need to know for now with regards to electricity. So the easiest way to think about an electron is like its bioinformation. So electricity is the flow of information, and magnetism is the storage of that information. So electricity is the flow of electrons, and magnetism is the storage of electrons. Yeah? So this is his famous quote. The body is electric. And we understand electromagnetism, and we don't even realize it, because how many of us have a smartphone? Hands up. Smartphone. Every single one of us. So the fact that you've got a smartphone, you understand electromagnetism, because you know that your phone is powered by electricity. Yeah? You know that the laptop is powered by electricity. These lights are powered by electricity. Yeah? With your phone, there's a magnet inside of the phone that stores the information. So that's electromagnetism. Electricity moves things or powers things, and magnets store things. That's the same in your phone. In your laptop, there's a magnet that stores the information. On a credit card, if you was to get your credit card and look at the back of your credit card, there's a black strip that goes on the back of the credit card. That is the magnet that stores the information. On an airplane, there's a black box on an airplane that stores the information, but it's electricity that makes the plane fly. So electromagnetism pretty much runs everything that we see around us. Electromagnetism. Now, having a phone, you'll start to understand certain things come with electromagnetism. So with electricity, you now know comes magnetism. They're one and the same. You can't have one without the other. Anytime there's a flow of electrons, there's going to be a magnetic field that gets generated around it. But what else comes with electricity? Well, just by looking at your phone, what else can your phone do? It lights up and it heats up. Okay, so with electricity comes light. Anytime there's electricity, there's going to be light, even if you can't see it. So with electricity comes light. And the sis says it heats up as well. So with electricity comes heat as well. So if you use your phone or your laptop for a long time, it starts to heat up. So all of these things are synonymous with each other. Electricity, light, heat, magnetism. What else can my phone do? If someone rings me, it might vibrate. So with electricity comes vibrations as well. Now, if you hear those vibrations, you'll hear them as sound. So with electricity comes light, heat, sound, magnetism, and vibrations. Yeah? They all come together. And you understand that just from having a smartphone. But what Dr. Sebi said is the body's electric. So that means that everything that your phone can do, you can do, or your cells. It was actually a black guy that made the cell phone. I wonder if he based it off of our own cells. Interesting. So when it comes onto electricity, if I'm explaining it to children, I like to use children's websites, because I feel like if I use a child's website, they should be able to explain electricity in a very simplified way. So this is from BBC Bitesize. So this is aimed at children. It says, what is electricity? Electricity is the presence or flow of charged particles. And electric current is the flow of electrons. So that's what electricity is, the flow of electrons, yeah? And this is an atom. To understand what an electron is, we have to go all the way back to physics at school. So this is an atom, the smallest unit of matter that exists in the universe, yeah? And you've got, in the middle, you've got the nucleus that consists of the protons and the neutrons. And then whizzing round the outside, you've got what they call the electrons, yeah? This is the smallest unit. These atoms come together to form molecules. Molecules come together to form your cells. Your cells come together to form your tissues. Tissues form organs. So this is the smallest part we're looking at. So these electrons, it's the flow of these guys that creates electricity. So if they're just whizzing around one atom, that's not electricity. It's when they go from one atom to another. When they start to actually move, that becomes electricity. And according to most scientists, this is the electromagnetic spectrum. So this is all of the electromagnetic radiation in the universe. Now, you might remember this from school if you were staying awake, because a lot of us didn't like science at school. But this is all of the radiation. I remember with electricity comes light. So this is all of the light in the universe as well. Now, I find this interesting because if you look at the whole spectrum, there's only a tiny part of the spectrum which is what they call visible light. Only a very, very tiny part of the whole spectrum. This is all of the light in the universe, yeah? But it's only this tiny part, which is visible light, which is what your eye can see, your naked eye can see, yeah? So any color that we see around us, we're seeing just this tiny portion of the spectrum. And then everything else is light that we can't see. So cosmic rays, gamma rays, X-rays, ultraviolet, infrared, microwaves, radio waves, these are all radiation. But remember, anytime there's electricity, there's light, there's heat, there's magnetism. So there's light here as well. Now, if this is true, then most of the universe is what color? Black. Most of the universe is black. Or black light, you could say, because this is light. It's not darkness because it's not absent of light. So most of the universe is black light. And again, everything that you see there is how they power up your phone. Yeah, so light becomes important because that's what we're going to be talking about if we're talking about electromagnetism. We're talking about light. And the only light that we can see is in this visible spectrum, which creates color. So anytime we see color, it's representing a vibrational frequency. Anytime we see color, it represents a vibrational frequency, which means that colors become extremely important in understanding science. Because a certain color will say how high the frequency is or how low the frequency is. These are higher frequencies, these are lower frequencies. So colors become important. Now, with that being said, we're going to start with an icebreaker. So you should all have a red, amber, green card in front of you. Red, amber, green. So we're going to go through colors right now. All right. Now, because a lot of people, when we start talking about health, has everyone got a card? If you haven't got a card, there's cards at the back. Everyone's got one. All right. Because every time we start talking about health, people go straight to nutrition. Like, what should we eat? What shouldn't we eat? Nutrition is just one part of health, yeah? So holistic health. Actually, before we go on to that, just very quickly, if I was to ask you, what does holistic mean? What would you say? Whole? Holy? Natural? Pure? Raw? Was that generic? Generic? Complete? Untainted? Balance. Let's put that one here. All right. So if we're talking about health, we can't just be talking about nutrition because that wouldn't be balanced. However, a lot of people, when they think of health, they think of nutrition. So let's start with an icebreaker. And that icebreaker is, if you was to put all foods on a traffic light system, red, amber, green, what would red foods be and why? Toxic foods. All right, to make it easier, what would red foods be high in? Sugar, fat, salt. All right, so red foods high in sugar, fat, salt, yeah? Now, I do this with the children, by the way. This is a very simple icebreaker. If we was to put all foods on this red, amber, green system, how frequently should we be eating green foods?
Every day.
Every day, yeah? How frequently should we be eating red foods?
None at all.
None at all? Not at all. All right, now this is the reason why I like doing this with children, because children, they use logic. They're very simple with how they think. If we was to say to children, don't eat something, like ban it, is that realistic for them? All right, so I always ask the children, per week, like frequency per week, how often should you be eating red foods? What do you reckon? Once? Okay, once. Sometimes the children say once or twice. All right. How often, frequency per week, should the green foods be?
Every day.
Every day. What about amber?
2 or 3 days.
2 or 3 days. All right. Here's what we say when we do it in the schools. So red is once or twice a week. Green is unlimited. Green is unlimited. There's no limit on how much you can eat. In other words, you can eat in the morning, afternoon, evening. There's no limit to green. However, amber, there's a limit. Amber, if you've eaten it that day, you shouldn't really eat it again that day. So you could potentially end up eating it like 4 or 5 times a week. But if you've eaten it that day, you shouldn't really eat it again that day. So it might end up being 3 times, 4 times a week. All right. With that being said, I'm going to show you some food examples, and all you're going to do is hold up red, amber, or green. So let's see. Now, if we're all in agreement, then we'll move on. If not, we might have to discuss it a little bit. All right, first one. A wide variety of fruits. Hold it up so I can see it. Green, everyone's saying green. We've got a red there for fruits. Fruits, red. Anyone want a red? Oh, amber. All right, why do you think it's an amber?
Even though it's natural, some fruits for some people it's still a lot of sugar.
Mm-hmm.
So for that reason.
Okay. All right. Now, again, when it comes to learning about health and nutrition, because there's so much confusing information out there, we have to try and keep it as super simple as possible. So when I go into the schools and I show children this, what do you think they show? What do you think they say? Green. Now, if I was to turn around to them and say, this is an amber, they'd probably think, then what's a green? If fruits are an amber, what is a green? Like, it limits the greens that we have out there, yeah? And again, we live in the UK, there we have a problem with childhood obesity. Now, there is a lot of sugar, but the point here is there's a wide variety of fruit. So you never want children or adults just eating one fruit all throughout the day. But a wide variety of fruits, you're getting a lot of vitamins, minerals, and yeah, children are not, they're hardly eating any fruits and vegetables, let alone making this an amber. Next one. Crisps. Red, amber, or green?
Red.
Red. People thinking about it. You can be honest, don't worry about it. Judgment-free zone right now. Okay. All right, red, some ambers. Okay. What about popcorn? Red. Red. People thinking about it. Red. Again, I'd like to do this with the children. Where would children be getting their popcorn from? Parents, microwave. Where are they usually getting popcorn from? Cinema. What's that going to be? Red, amber, or green? Red. All right. What about chips? Red. All right. What about baked potato? Amber. Okay. People are saying amber, putting up ambers. All right. Now, this could potentially be made into a red. How? What you're putting on top of it, more cheese, yeah? What topping and that sort of stuff, okay? What about vegetables?
Green.
Green. Everyone says green. All right. What about pizza?
Red.
Again, you can be honest. This is judgment-free zone. Yeah?
The cheese alone is fatty.
Okay. What about this?
Red.
Seeing a lot of reds. Seeing a lot of reds. Couple ambers. Reds, ambers. Okay. So, you got to be careful with this because, yeah, there's not a lot of cheese, but what's this made of? Yeah? Now, this could be made healthier depending on what type of pasta you use. Yeah? Or spaghetti you use, like spelt spaghetti. We're going to talk about that later on in the course. And what type of sauce. But obviously, as it is, most of you said amber or red. What about this? Fried chicken. Red. Now, again, I like to do this in the schools. So when I go into the schools and I do this, what do you think the children say? Again, the children are very logical. The children say red. But how do they eat it? They eat it like it's a green. They eat it every day. Yeah? So they know they shouldn't be eating it every day. They say red. When I show this, they say red. They understand. But they eat it every day. Every day after school, children are in the fried chicken shop eating this. So they know. That's interesting. They know that it's a red, but they eat it like a green. What about this?
Red.
Some amber, some red. What about red meat?
Red. Definitely red.
Red. Yeah, studies have suggested that this is carcinogenic, so causes cancer. What about fizzy drinks? What about energy drinks? Red. Everyone's saying red. Yeah? giving you energy? Yeah. All right, what about chocolate? What kind? Yeah. It's always interesting. When I do it with the children, they'll just say, yeah, red, but adults, what kind? What kind are we talking about? Because if it's dark, if it's dark. All right, well, let's start with milk chocolate. If it's milk chocolate, what is it?
Red.
Red. Everyone agree? Yeah. Now, why is it a red if it's milk chocolate? Because it's high in sugar and dairy. All right. So dark chocolate, what would you say that is? Amber. Okay. What makes the dark chocolate healthier? It's got something natural. Some people say, yeah, I've heard it's got antioxidants. And so it's things that you're hearing, yeah? However, what you'll find is that milk chocolate is high in sugar. But remember, you guys said that a red is something that's high in what? Sugar or salt or fat. Dark chocolate is high in fat. Dark chocolate is high in saturated fat, yeah? But it does have, because of what it's made of, it does have antioxidants in it as well. So that's what gives it the quote-unquote health factor, yeah? But dark chocolate is high in fat. So you've got one that's high in sugar and the other one that's high in fat. So if we're going by just the definition of the red, which is something that's high in fat and or sugar, then they would both be a red. What about this, which is sandwiches that people get when on their way to work or at lunchtime and that sort of stuff? Most people saying red, okay. What about water? Green? Okay. Depends where you're getting it from. All right, we're going to go through water later on in the course. Alcohol? Red, everyone agree? I know some were like, no, not red. Not red, come on. Not my alcohol. What about milk? Everyone's saying red. Some people putting up amber. Cow's milk?
Definitely red.
Definitely red, okay. What about eggs? Some people say amber, a lot of people saying red. What? So we went through this. Fruit juice, red, fruit juice. What about cut up fruits? You'll find these in Tesco's and Sainsbury's ready-made cut up fruits. Amber. There's been studies to suggest that because of the utensils that they use to cut it up, it could be contaminated. And you don't know how long it's been on the shelf as well. So that makes it a red, yeah? They usually put something on it as well. Yeah. And then what about this one? Coffee. Red. Amber. Okay. Okay. Again, when I do this with adults, they'll say depends and that sort of stuff. But adults who drink coffee, how often do they drink it? Sometimes 3 times a day. So for the adults, this is a green. The adults who drink coffee, this is a green for you. You drink it like a green, yeah? But it's not. Should actually be a red. Now, when I show this to the children, what do you reckon they say? They say, what is that? Because remember, they're not at that stage where they have to rely on this to get up and keep them up all day, yeah? They're like, what drink is that? Because they don't drink coffee, yeah? Now, I always do this in the schools, colleges, and universities, and I get the same result. The children say they put up the greens for the greens, the ambers for the ambers, and the reds for the reds. In other words, we know what we should be eating and what we shouldn't be eating. So I have a question. Why do we tend to eat more red foods than green foods?
What we've been brought up on.
All right. More addictive. All right, let's write these down. Let's write these down. So, someone said addictive. What else? Attractive. Convenient. Marketing. Advertising. What was the other ones? Misinformation. Feels good. Yeah. Feels good. misinformation, availability, what else? Stress, budget, comfort. Anything else? Cycles. That's to do with emotions. Tradition. Tradition. Anything else? Sorry, what was that? Environment. Yeah. All right, one more.
To make it look attractive.
Yeah, attractive. Yeah, that's part of marketing, so. All right. So why do we tend to eat more red foods than green foods? Now, here's where I'm going to introduce to you a scientific theory. So this is on page 3 of your notes. The pleasure principle. Freud, this is from Sigmund Freud, so one of the famous psychologists, one of the famous scientists. Freudian psychology described the pleasure principle of human motivation. It said that people are motivated towards pleasure and away from pain. Hence, it is also sometimes called the pleasure-pain principle. In other words, he said he broke down everyone's motivation, human motivation, down to 2 motivating factors, pleasure and pain. If you were to break down everything that a human does, it's due to one of these 2 things. It's either to seek pleasure or to avoid pain. Think about everything that you do in life. If you were to break down what you're doing, it's to seek pleasure or to avoid pain. Even going to work. If you're going to work, the reason why you are going to work is to do one of 2 things. Either seek pleasure, it might be the money you're making, that's pleasurable, or to avoid pain. You want to make sure that you're paying your bills and you don't get, evicted from your house or whatever. So everything that a human being does, it can be broken down to these 2 motivations, pleasure and pain. Either seeking pleasure or avoiding pain. Now, here's a question. Which one do you think is more powerful as a motivating factor?
Pleasure.
Pleasure. Hands up who thinks pleasure. Interesting. Who thinks pain? Interesting. All right. So, here's another question. So, pleasure-pain principle, is this the reason why we're going through childhood obesity? So is this the main cause of obesity, pleasure, pain? So if we go back to the red, amber, green, the red foods are pleasurable for most people. Like someone said there, it feels good. Feels good eating those foods, yeah? So the red foods are pleasurable. And again, the easiest way to understand this is thinking about children. They find pleasure in eating the red foods, and they actually find pain in eating the green foods. Literally. Because we like to think that pain is just physical. Pain is not just physical. Pain can be emotional, pain can be mental, pain can be psychological, pain can be spiritual, and pain can be you tasting something and finding it disgusting. That's a painful experience for a child. So if you say, eat this broccoli to the child, and the child eats the broccoli and they're like, that's disgusting, that's now registered as a painful experience to the child. So if that's the case, they find the green foods, the foods that are good for them, literally green foods like broccoli and all the other green foods, painful, and all of this, all the sugary stuff and high fat stuff, pleasurable, yeah? But we can go deeper. Someone said about addiction over there, addictive. If we used to go inside of the brain, we've got these things called neurotransmitters. These are the structure of neurotransmitters. Now, chances are you might not know all of them, but you should know some of them. So we've got adrenaline. We know what that feels like when that gets released. Noradrenaline. Serotonin is the mood neurotransmitter that makes us feel good during the day. It gets released during the day. Endorphins, for people who exercise, you know about this neurotransmitter. But look at this one, dopamine. The pleasure neurotransmitter. This gets released in the brain after feelings of pleasure. So it's associated with addiction. But dopamine is also associated with movement and motivation. People repeat behaviors that lead to a dopamine release. So this is very important when it comes to the addiction. And you know what releases dopamine in the brain? Heroin, cocaine, and sugar. They release dopamine. They actually activate the same parts of the brain as drugs, sugar, yeah? So the children who say they love it may not even be true. They may not just love the food. They're actually addicted to the food due to this neurotransmitter, yeah? Now, when I'm explaining science, I like to break things down very simple and use analogies and that sort of stuff, because I feel like, especially when I go and teach science to the children, I want to make sure that they really get it and understand it. Now, through me understanding science, I found that the best way to understand science is to break down the language that they use.